Example 1. A function defined as an integral. If f is a function whose graph is shown here in figure 2, and g of x is equal to the integral of f of t dt going from 0 to x, we want to find the values of g of 0, where x is 0, when x is 1, when x is 2, x is 3, and x is 4, and 5, and then sketch a rough graph of the following of g. Okay, so let's go ahead and start with number 1. All right, so number 1 is when we're going to let x equal 0. So when we find g of 0, that means we're letting x equal 0 into the integral. So we're going to go from 0 to 0 of f of t dt. Well, we know that that's going to give us 0 because the fact that we have an area going from 0 to 0 is going to give us 0. So that means that this location of 0 right here, we know that that's going to give us an area of 0. Okay, now let's take a look at 2. So when we let g of 1, that means that x is going to equal 1. So we have an integral that's going to go from 0 to 1 of f of t dt. Okay, now let's take a look at that. So that means that from 0 to 1 over here, we can see that we end up having a triangle. And what do we know about the area of a triangle? We know it's going to be 1/2 times the base times the height. So that means we're going to take 1/2, and then we're going to multiply 1 times 2, which is then going to give us an area of 1. Okay, let's take a look at number 3. We have g of 2 when x is equal to 2. So we have the integral that goes from 0 to 2 of f of t dt. Okay, well that means that we're adding the integral, which is the first one. So we're taking the integral going from 0 to 1 f of t dt, and then we're adding the integral from 1 to 2 f of t dt. Okay, so let's take a look at that. Well, we know that from the second step, we know that this area is 1, plus now we want to find the area of this figure, which we can see represents a rectangle. So that means it's going to be the length times the width, so that is 1 times 2. And so therefore, 1 plus 2 is going to give us an area of 3. Okay, now what we want to do is we're going to find g of 3. So that means when x is equal to 3. So if we take a look at g of 3, what do we know about g of 3? Well, we know that it's going to equal g of 2 plus the integral going from 2 to 3 of f of t dt. Okay, so that means that we're looking at this scenario here. We want to find the area of that part going from 2 to 3. Okay, so we already know that g of 2 in step 3 is equal to 3, plus now what we're going to do is we're going to estimate this triangle, okay, because this is a triangle. So that triangle is going to be 1/2 the base times the height. Okay, so if we take a look at that, 1/2 the base times the height, okay, which is approximately, we would say, it's a little over that. So we would say it's about approximately 1.3. And so therefore, we approximately get 4.3. Okay, next. We want to find g of 4. So that's when x is going to equal 4. So recall that g of 4 is going to equal g of 3 plus the integral that goes from 3 to 4 of the function f of t dt. So that means we're looking at this piece. Okay? So we know that g of 3 is approximately 4.3. Okay, now if we notice here, this is positive, this is positive, this is positive, so we're adding all 3. Now we need to subtract this amount. So we're going to subtract the approximation of this. And since this is similar to that one, we can say that that represents minus 1.3. So 4.3 minus 1.3 is going to give us approximately 3. Okay, now let's take a look at g of 5. So if we look at g of 5, where x is equal to 5, we know that g of 5 is going to equal g of 4 plus the integral that goes from 4 to 5 f of t dt. Okay, so again, this is going to represent this piece here, going from 4 to 5. So we know that g of 5, we know that g of 4 from step 5 is 3. Okay, and then again, since this is underneath the x-axis, we're going to subtract, and we're going to subtract the estimate on that. And the estimate is 1.3. So we end up getting approximately 1.7 for the area of that particular figure. So again, the total area under this curve, is going to be 1.7. Okay, now we also want to be able to then sketch a rough graph of g. So let's take a look here. So from 0 to 1 to 2 to 3, we know that it's positive. And then from 3 to 4 and 4 to 5, we know it's negative. So what is that going to tell us? Okay, well, we can see here, we use these values to sketch the graph of g in the figure below over here on the left. Notice that because f of t is positive for when t is less than 3, so that means it's positive here. So that means we keep adding the area for t is equal to 3, and so therefore g, this function starts at 0, is going to increase all the way until it gets to the value of 3. Okay, and then that's where it attains the maximum value. So therefore the maximum value is going to be here. Okay, and then for when x is less than 3, we see that the function g decreases until it gets to 5. So from here, it's going to decrease all the way until it gets to 5. And again, that's what this is telling us when we're sketching this graph.